Squaring numbers is something that can be done reasonably easily in your head. And the first pattern we'll look at is squaring numbers that end in 5. So the first few, hopefully you know. The rest, we're going to see if we can find a pattern. 5 squared is 25. 15 squared is 225. 25 squared is 625. Now, even at this stage, you'll probably notice that they all end in 25. And that is a consistent feature. 35 squared, you may not know, is 1225. 45 squared is 2025. So we're still getting the 25s. Let's see if we can figure out how we're getting what precedes the 25. In the first case, there's really nothing in front of the 25, and there's nothing in front of the 5. For 15 squared, how do we get from 1 to 2? Well, you can think of it as just multiplying 1 by the digit higher than it. 1 times 2 is 2. For 25 squared, 2 times 3 is 6. For 35 squared, 3 times 4 is 12. For 45 squared, 4 times 5 is 20. So as we keep going, 55 squared, just take the first digit 5, multiply it by the next higher 6 to get 30. And then finish it off with a 25. 65 squared, 6 times 7 is 42. So 65 squared is 4225. And you can keep on going. 75 squared is 5625. 85 squared is 7225. 95 squared is 9025. 105 squared is 10 times 11, 110. And, you know, this pattern will always work. But of course, once the numbers get big enough, it's not exactly trivial to multiply one number by the next highest number. Now, why does this pattern work? We're going to find out why and then learn how to extend it to squaring any number. And the reason it works is because of the difference of squares pattern. So if I have a difference of squares, this factors as a product of binomials, and the binomials look almost the same, except that there's 1 minus and 1 plus. They are called conjugates. Now, if I just take the minus b squared and I add it to both sides, it'll disappear from the left, and I'll have this product of conjugates, a minus b, a plus b, and then I'll have the plus squared on the right. So this is actually the pattern that we're taking advantage of when we square 5s, and you can take advantage of the pattern to square any number. For instance, when you're squaring 35, you have to figure out an appropriate number to replace b with. And it's obviously easier to multiply numbers that end in 0. So if we subtract 5 from 35, and then add 5 to 35, and then finish it off by adding 5 squared, you can see that this 35 minus 5 is just 30, and the 35 plus 5 is 40. And then you're finishing it off by adding 25. So 30 times 40 is pretty easy because you're just really multiplying the 3 times the 4 and adding 2 zeros. So there's your 3 times 4. And since it's always going to end in 2 zeros using this pattern, that's why it always ends in 25. So we get 1225. Now, can we extend this to squaring any number? The answer is yes. And sometimes it can be remarkably easy to square large numbers. I'll start with something that's not too impressive. Let's say you want to square 48. So 48 squared. The idea here is to pick a number that's close to 48 and is a nice round number, like 50. So 50 is 2 away from 48. So what we're going to do is set up our product of binomials as 48 minus 2 and 48 plus 2. And then simply have to add 2 squared to it. So 48 minus 2 is 46, and 48 plus 2 is 50. Now, it's not quite as easy to multiply 46 and 50 as it is to multiply 30 and 40, but it's actually not too bad because 50 is just half of 100. So 46 times 50 is just half of 46 times 100. So it's 2300 plus 4, so 2304. And obviously the goal here is mental math, so the idea is to be able to do this in your head, and it does take some practice, but with some practice you find actually the hardest thing sometimes is the subtraction. So here's where it gets quite impressive. You can do something like the following: 987 squared. Now, this is a particularly nice one to do because 987 is very close to 1,000. And it would be very easy to multiply a number by 1,000. We just have to add 3 zeros. So how far away is 987 from 1,000? It's 13. So if we simultaneously subtract 13 and add 13, all we have to do then is add 13 squared. And again, this part becomes the trickiest part. 987 minus 13, which is 974 times 1,000 plus 169. And might help to know 13 squared, otherwise that might be a little tricky too. So this is just 974,000 plus 169. And as I said, with some practice, you can do some pretty impressive things in your head.